Alright, let's talk about rollback today. Before we get started, I want to mention that if you haven't already seen Core A Rollback's video, you should check that out first. That is probably the #1 casual resource on rollback. It'll help explain the basic concept of the idea. But the point today is to dig a little deeper. While I was learning rollback, I noticed there are no resources for developers. The closest thing we have is the GGPO official documentation, official PDF. I'll say that's not very helpful. It also only introduces the basic concepts. It gives a brief overview of everything, and then it just leaves you with that. So let's get into a little bit more detail. Alright, so let's start with the input structure. Basically, every button will have a pressed and released boolean, and we'll be keeping track of the frame so that the other player knows what frame we're talking about when we send this input to them. And we'll have a isEmpty boolean function. If every single pressed and released is false, then we don't care because we got it right. We only care when we got it wrong because that's when we need to roll back. The state will also be sending the frame so that we know which state we're talking about at what point in time. And then we'll be sending the bare minimum amount of data to make sure that we are synchronized. That'll be position, health, and then a few other things that we'll come back to. Moving on to the next part, both players have a input array. That is this structure in an array. And both players have a local structure and a remote structure. This remote structure for player 0 should be equal to the local input of the other player at the end of the round. While we're chugging along, say this is at frame 10, this is also going to be at frame 10, but say we have a 3-frame ping, this is only accurate up to frame 7, or whenever the last frame was received, which should be frame 7. And frame 8, frame 9, and frame 10 will be blank. Let us be filled up blank. And so if we receive an input for that frame and it's also blank, then we just keep going on. We don't roll back. Everything's good. Alright, so let's do a little demo of what this would look like. At frame 0, player 0 presses right. And so player 1 doesn't know yet. He's just chugging along. He's pretending like he didn't see anything, which he did not. And then at frame 3, he sees, oh, you sent me an input at frame 0. So what we're going to do, we're going to go back. We're going to pretend like the whole time we knew he pressed right at frame 0. We're going to go back. We're going to recalculate our state based on if he had pressed right at frame 0. Maybe nothing changes besides the position. That's fine. But once we get here, we're going to pretend like this old path never happened. It's not rollback netcode. It's gaslight netcode. It never gets anything wrong. You know, you're just seeing things. And here's what it looks like for player 0. He's chugging along. It's frame 3. And that's it. He doesn't care that the other guy was out of sync. He doesn't care when the frame was received. He only cares if he receives an input that was not empty. Alright, so let's build up to why state is important. And why sending state and receiving state and ensuring that they are synchronized is important. So let's say at frame 0, player 0 sends a fireball. It's a 1-button fireball. He pressed it and it's gone. At frame 3, player 1 receives that fireball. He rolls back. He did everything correctly. At frame 3, we're all synced up. But Player 1 presses right at frame 4. Player 0 drops this input, never receives it. And then at frame 8, player 1's HP is 100%. But player 0 says, hey, it's at 85. You didn't dodge that fireball. You should have took 15 damage. And so player 1 will be like, nah. Here's all my inputs from frame 0 to frame 8. Run it yourself and make sure that I'm right, because I know I'm not wrong. So player 0 says, alright. He says, give me all of that. And so he gets it. He goes back all the way to frame 0 and replugs it. And then he says, oh, you forgot to send me this move right at frame 4. So basically, the desync wasn't that bad. It was 4 frames. He's going to go back here. He's going to fix it up. And everything's good. We're going to continue along. But we only caught that because the state sync occurred and made sure everything was the same. Nobody cheated. Nobody did anything wrong. Say we get these inputs back and he didn't see this input at frame 4. He's going to say, hey, you cheating, bro. Let's close this game out. Alright, so let's talk about the state. Let's talk about has fireball active. And let's talk about fireball frame started. So basically, I don't care about the fireball position or the speed. The speed is always going to be the same. It's never going to change. So I don't need to pass that around. Both players should be in agreement about where the fireball is. Say one player is cheating and he made his fireball twice as fast. I'm going to see that difference in the health. I don't need to pass the fireball speed. Alright, and now let's talk about the fireball position. As long as I know when the fireball was started, I don't care about the fireball position, because with a fixed time step, I can go back to my character position when it was started, and I can work back into that position. And it'll always be the same as long as I have those two variables. Alright, so let's talk about a mistake I made that you may have noticed. So, why do I care about the fireball frame started? I have a frame right here, correct? So, what I can do is I can come back, I can say fireball thrown. And then when I step into the next frame, fireball thrown is false. So I can tie that true fireball thrown into this frame right here. So I don't need fireball frame started. I don't need fireball active. I know when it'll go inactive. I know how long it's been active just based on this bool and this frame right here. And why do we care about that 4 bytes we just saved? Well, if we do that multiple times, let's say we half the size of our state, we're sending it twice per second, 60 times a minute, and then our average guy plays 8 hours a day, 30 days a month. He's pretty hardcore. We'll save him about 100 megabytes a month. Yeah, it's not a lot, 100 megabytes, you know, nobody cares about that. But let's say we have 10,000 players times, what was that, 100 megabytes? Now we're talking about saving your servers 976 gigabytes per month. Say you have 1,000, you're saving 97 gigabytes a month. That's money right there. Say your average guy plays 2 hours a day, you know, you're still saving a lot of data. Alright, so we talked about the logic of rollback. Let's talk about the netcode. There is 2 important variables. One is the latest consecutive frame, and one is the latest frame received. Latest frame received is pretty simple. If you receive a frame that's greater than it, then it is equal to it. And then latest consecutive is a little bit more complicated. Basically, we want to make sure there is no gaps in between the frames we receive. So we will be comparing our latest frame received to our latest consecutive frame frequently. And let's take a look at what that would look like. The slippage is equal to the ping minus the difference in frames. Say my current frame is 100 and my latest frame received is 72. So that difference is 28. my slippage would be -8. And so say my threshold is 8. My slippage is greater than my threshold, so my logic loop is going to take longer to perform. To all the variables in my logic loop, I'll always pass the same number, be it 1 divided by 60, if I'm doing 60 ticks per second. But the logic loop itself will take slightly longer if I detected a difference in run speed between the two clients. And maybe that wasn't good enough. Maybe I have a bigger threshold. Let's say this is 12. So the difference between my frames is 32 and my ping is 20. Now I've detected that I'm having an issue. One player may have dropped. They may have lost a decent amount of packets. Their net might have gone down. They might have auto forward, who knows. But I'm going to pause here. And I'm going to wait for them to send me everything. I'm probably going to send a few packets to them telling, hey, we lost sync. Send me everything from latest consecutive frame. And that should get us back in sync, assuming it was just a minor issue. Say they lost 10 packets in a row. We should be able to catch back up. And we'll do another comparison. Packet drop equals latest frame received minus latest consecutive frame. If this packet drop value is like 2 or 3, it's not a big deal because we're using UDP and the packets may arrive out of order. That's fine. But if it gets up to like 5, maybe 8, it's not okay, and they most likely drop the frame that we won't receive unless we ask for it once again. And there is 2 ways that we can mitigate packet drops. One is we can send multiple frames at once. We could send the last 5 frames, last 10, whatever. Or we could use a variable called latest consecutive confirmed. Basically, we'll be telling the other guy what our latest consecutive frame is at all times. And that would be this variable. And then when you send a frame, you would send everything from that value to your current frame. So say you drop 2 or 3 frames, like those are never going to reach the receiver. Basically, in this method, you would keep sending those frames over and over all the way until they say, yeah, I got them. But in this method, you don't care if they got them or not, you're just going to send the last 5 frames no matter what. So if you drop, say, 6 frames, that 6th frame is never going to be sent until it's requested once again. And there are pros and cons to each method. In this method in particular, it will use the least data, but it is the most unreliable. In this method, it is fairly reliable. You only lose sync if they drop more than 5 packets. And in this method, you will never lose sync, but say the ping is worth 20 frames, you will always be sending 20 frames, which is 4 times this usage. And that's about it. I think I covered everything. I know it can seem like a huge monstrosity before you get started with rollback, but it's really not that bad once you get into it. Just remember, we're not predicting anything, we're just gaslighting our users into thinking we always know what's going on. I'll be linking a whole bunch of resources in the description, and if you have any more questions, I'll be happy to answer them in the comments.